Yes, recording. Now for NOR gate, we need for not two input NOR gate. Again, we need two PMOS and two NMOS, but the difference will be the connection. Okay. Before the NMOS were series, now they will be in parallel. This one. This is your A. This is your B. Let's connect. This is your Y. Now the A should be connected with one PMOS. Which one, the upper one or lower one, doesn't matter. Remember, it doesn't matter. Which one is A, the right one or left one, doesn't matter. It's your wish. Okay. Now, I think the connection is completed. So if you wish, you can rename it. You can rewrite it as A. You can rewrite the name as B. And you can rewrite the output name as Y. Okay, that's it. Now here, let's check. Let's check. Oh, before checking, let's draw a truth table. This is your A. This is your B. Oh my God. And this is your Y. Let's give 0, 0, 0, 1, 1, 0, 1, 1. So why we are doing this actually? Because this thing is needed for your lab number 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5, 6, you need this sort of design. That's why we are trying to make you ready for the labs, and you need this for your theory courses as well, because theory courses have some questions. I might ask you to design this on paper. So that's why you need this first. Okay. Now here we will try to get the truth table. Normally for NOR gate means A plus B bar, right? Y is equal to A plus B bar. That was the truth table. A plus B bar. That is your NOR gate. Y is equal to A plus B bar. Remember, A plus B bar. That means 0 plus 0, that means 0. 0 bar is equal to 1. So here you should get 1. So, okay, let's write them first with yellow color. You should get 1. Then 0 plus 1. 0 plus 1 is equal to 1. 1 bar means 0. So you're supposed to get 0. Supposed to. Then 1 plus 0, that means 1. 1 bar, that means 0. You are supposed to get 0 again. So 1 plus 1, 1. 1 plus 1 means 1. Bar, that means 0. So you are supposed to get 0. So let's check whether we get the same thing or not. Okay. I'm going to switch it off. Then I'm going to run it. Now for 0, 0, you are getting 1. So obviously it is correct. For 0, 1, you are getting 0. Correct. For 1, 0, you are getting 0. That is also correct. For 1, 1, you are getting 0. You are so our truth table is correct, right? So our NOR gate is completed. Now, how they works actually? When both of them are 0, that time your both of the NMOSes are off. That means your ground connection to the LED is off. No ground is connected. So what is happening? Your both PMOSes are on, So current will come, current will come, current will come, current will come. Then it cannot go to the ground because okay, do not talk. Okay. So current is coming, 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 coming. It cannot go to the ground because the connections are off, right? So what it can do? It can go to the ground through LED. It can go to the ground through LED. Remember this, when it go to the ground through LED, the LED will be on. That means you have 1. And when your input is 0, 1, that time this is on, right? For 0, PMOS is on, but for 0, the NMOS is what? NMOS is off. What is happening? Current will come, but current cannot come because you have a open circuit. So since current cannot come, so it cannot go to the LED, so LED is off. And again, your ground, right? Ground is connected through this path. So your LED has 2 ground. In one pin it is ground, in another pin it is also ground. So both of them are ground, that means you are getting 0. For 1, 0, again, this PMOS is off, that means current cannot come. If current cannot come, that is 0. So this is connected. For 1, 1, both of the PMOS are what? Both of the PMOS are off, that means current cannot come. But ground is also connected. Ground is connected to the point, right? Put to the LED, that means you are getting 0. So this is actually your what? This is actually your, what is that called? NOR gate, right? This is your NOR gate. So if I want to make OR gate, how can I do that?
Just include a NOR gate within it.
Exactly. So we have to oh my god, wait. We have to include these NOT gate. Remember, so this is your NOT gate. So your output will be A plus B, right? Not bar. Remember, A plus B. So let's try. So when it is 0 plus 0, it is 0. 0 plus 1, it is 1. 1 plus 0, it is 1. 1 plus 1, it is 1. So it is a NOT gate. It is an OR gate, right? It is an OR gate. Understood?
Yes.
OR gate. Now, if you need an OR gate that has 3 inputs, like this, plus C, what you can do?
We can include a PMOSFET and a CMOSFET.
Exactly. So you have to include one NMOS here, like this. This is your C, and we have to include one NMOS here, right? Now PMOS actually, not NMOS. You have to include one PMOS here, right? Or here, you can include it here as well. Or at the middle, you can include it here as well. No problem, doesn't matter. Sequence doesn't matter. So ABC or ACB or CAB doesn't matter. Where you want to include it, no problem. Understand? So remember, for NMOS and PMOS, wherever you connect it at the middle or at the last, doesn't matter. So when you need 3 inputs, you need 3 PMOSFET and 3 NMOSFET. That is the thing. Now, I want you to understand one very important thing, that our series parallel combination, okay, let's switch it off. And I don't need this because I told you, you do not have to show me the buttons when you design it on paper. Okay, remember, whenever you design it on paper, you do not have to show me. You do not have to, but when you design it on the software, you have to give it. Otherwise, it will not work. You do not have to show me what? You do not have to show me the input. You do not have to show me the output device. You do not show me the connections, all connections. These connections is important. These connections are important. but the input connections and the output connections you do not have to show me. Okay, you can just write. You can just write A, B, A, B. Okay, and that is your Y. Okay, understood? A, B, and that is Y. Now, what is happening here? Before, when our equation was A into B, that means NAND, right? A into B bar. That time, our NMOS was what? NMOS was series, right? Our NMOS was series and our PMOS was parallel. So I'm writing NS. NS means NMOS series, PP. PP means PMOS was parallel. Understand, when it was multiplication. Multiplication means NAND. For NAND, the NMOS was series, PMOS was parallel, right? But for now, when it is addition, that means A plus B or A plus B bar. When it is A plus B bar, our NMOS is parallel now. This is a very important observation. Otherwise, if you do not understand this observation, you cannot design the next circuits. And your PMOS is series. Understand? Now here, remember this. Otherwise, if you do not remember this, you cannot design it. Remember that this to design. NMOS design. No, that means your NOT gate design, your NAND gate design, and your NOR gate design. You have to remember these three designs. Otherwise, you cannot design the complex designs. Okay. So when your design, when your expression is A into B, that means multiplication, like this one. When your what is that? When your expression is multiplication A into B, that time your NMOS should be in series and PMOS should be in parallel, like the previous one. When your expression is addition, that means A plus B, your NMOS should be parallel and your PMOS should be series. What do I mean by that? Let's design something, then you will understand. Okay, let's go back to a empty place. I want to erase this. Now, so I want to design something, this one, Y, oh my God, is equal to AB plus C bar. I want to design it. Okay, AB plus C bar. Here you can see you have multiplication and you have addition both, right? So how to design it? How can we design it? Okay, let's wait for 10 seconds. Yeah, I'm back. So we have to design this AB plus C bar. So look at this very carefully. Here you have two things, AB plus C bar. Now you cannot, now at the beginning, obviously I can, but you cannot. At the beginning, you cannot design it as a whole. You have to design it step by step. So, okay. So what you have to do, you have to think this expression. You have to think this expression separately. So if I tell you to divide this expression into two parts, okay, Nazifa, you explain it to me. If I tell you to divide these expression into two parts, how can you design? How can you divide? How can you divide the expression? You have to divide the expression. Are you listening? Okay.
Sir, I just unmuted myself. Sir, the design section or just the equation I need to
The
design?
equation, just the equation. If I tell you to, okay, this is your expression. See, wait a minute. I'm going to write it again. তুমি আনমিউট অবস্থায় থাকো, তুমি দেখো y is equal to a b plus c, উপরে একটা বার আছে, বারটা দিচ্ছি, ওয়েট করো, I'm going to give the bar. This is the bar. Okay, if I tell you to, we have to design it, but before that we need to divide this expression into parts. Okay, দুইটা পার্টে ভাগ করব আমরা, we will divide this into two parts. So how can you design it? How can you divide it? কিভাবে ডিভাইড করবা?
একটা ইকুয়েশন ছিল, আমি ঠিক ইকুয়েশনটা আমার মনে নাই, কি একটা সূত্র ছিল
হ্যাঁ, ওইভাবে
ভাঙিয়ে ফেলতে পারবো আমরা।
আমি ওটা বলি নাই, আমি বলতে চাচ্ছি যে লাইক দিস, whether someone can say, okay, y is equal to a is one part, b plus c, this is another part. তুমি এভাবে বলতে পারো। Okay, you can say, okay sir, so a is our one part and b plus c is our another part. This is one way of doing it, but this is not correct, this is wrong, right? এভাবে করা যাবে না। If there was a bracket here, we can tell, okay sir, b plus c is one part, a is another part, but actual rules will be ab is one part, c is another part, right? So if I tell you to divide these, if I tell you to divide these into two parts, your answer will be, sir, this is our answer, ab is our one part and c is another part, right? So ab and c. So can you understand, can you see that a, b and c, they are added, they are being added here? So if I for some reason, if I take the ab and then replace it by x, if I replace it by x, that means your ab is equal to x, right? If I replace it by x plus c, so obviously you have a bar. I didn't remove the bar. Bar is there. So x plus c bar, which gate it is? এটা কোন gate?
এটা হচ্ছে কি x or gate.
It's a NOR gate. NOR gate, right? Yes. Let's design the NOR gate. No, not here. Not here. I'm going to design it here. আমি এটা এখানে ডিজাইন করব। So I told you before, NOR gate কি হয় জানো? In NOR gate, NMOS are series or parallel? Which one?
NOR gate is AND gate হচ্ছে parallel আর
Okay, write this and remember this throughout your life. For a into b, that means multiplication. That means what? Your okay, I'm just going to write like this. For multiplication, your NMOS will be series and your PMOS should be parallel, right? Remember this, for multiplication, your NMOS is series, PMOS is parallel. For addition, your NMOS is parallel and PMOS is series. Okay. Remember, for multiplication, that means A into B or AB, NMOS is series, PMOS is parallel. For addition, your NMOS is parallel, PMOS is series. Okay. Do not forget these throughout your course. Do not forget this. Otherwise, you cannot design it. Now, I'm going to write it here at the corner. So here, what do you have? You have X plus C, right? X plus C. So they are addition or multiplication?
Addition.
Addition. Addition, for addition, NMOS will be what?
Parallel.
And NMOS will be parallel, right? Obviously, NMOS is parallel. So here, what I have done, I have done parallel. So X and C, they should be parallel. Parallel means like this. Okay. So they are parallel. This is PMOS, this is NMOS part. Always make your design. Remember, this is a very important topic, important suggestion as well. Always design your circuit from the bottom. Okay, from the bottom. That means you design the NMOS first, then PMOS. If you can memorize, if you memorize the circuit, then you can design from the top to bottom. But if you do not memorize the circuit, that means you have to design it for the first time, right? That time, design it from the bottom. That means NMOS first, PMOS later. Okay. So I am designing the NMOS first. So our NMOS should be parallel. See this one, NMOS is parallel, right? So X and C, they are parallel. So at the bottom, you have your ground. Pretty simple. You have your ground. Okay. So since they are parallel in NMOS, so what should they do in PMOS? PMOS কি করবে?
Series হবে, sir.
Series.
Yeah, they will be in series. So here you have X, then you have C, right? So our connections and our design is 50% ready, 50%. And since you have a bar, right? Do you have a bar? Do you have a bar? You have a bar, right? Since you have a bar, you do not need any NOT gate. If you do not have any bar, if there was no bar, you have to add one NOT gate. Now you have a bar, you do not need, right? Understand? No need. No need. Okay. So this is your Y actually. This is your output, final output. Remember this, bar means no NOT gate, not bar, that means NOT gate. Okay. Okay, now come here again. C. What is C actually? C is actually C, right? C and C. C is actually C. C is only one what? Only one input. So can we replace the C using one what? Using one NMOS, can you do that? Because you have only one input, C. C is one, C is single. That's why we replace the C using what? NMOS. In case of this one, again, C is single. So can we replace that? Using a single PMOS? Of course we can, right? Obviously, this should be at the middle. So this is your C. Who didn't understand this? Okay, I believe all of you have understood. Since C is the simplest one, C was the simple, because C is C, right? That's why we remove that circular portion and we redraw the C. NMOS is NMOS, PMOS is PMOS. Now X, for X is not that simple, because X is not X. X is actually AB, right? X is actually AB. So X is not, you cannot replace the X by using one NMOS or one PMOS. But think about this one. Your X is equal to A plus what? No, 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 not A plus.
AB.
AB, AB. AB. Is it plus or multiplication?
Multiplication.
Multiplication. For multiplication, your NMOS, this is your NMOS part. This part, the lower part is your NMOS, right? Your NMOS should be what? No, no. For multiplication,
Series.
should be series, right? Should be series. That means your AB, they are multiplied, so they should be series. Here they should be series. Remember, see, they should be series. A and B should be series. So I'm going to draw them in series. This is your A, your B. Understand? Since AB, that means the whole part was X. X means whole part was AB, right? Since AB was multiplied, so NMOS will be series. So this is your A. This is your B. Again, this is your AB. This X part will be your AB as well. This is your AB as well, right? Because X is actually not X, it is actually AB. Now, we already did the NMOS part. Now we will do the PMOS part. But for PMOS, multiplication means what? Series or parallel? Parallel, obviously. It is parallel. So since it is parallel, we are going to remove these and we're going to draw as parallel. Parallel means A is here, B is here. So bubble, this is your B. Or this can be A as well, your wish. B, A doesn't matter. It's too tough to draw something on computer. I could have done it faster.
Yes, sir. ডিজাইন করলে ভালো ছিল, ওটা ভালো বুঝে যেত।
ঠিক না, কিন্তু এটাতে তুমি আমি ওখানে ডিলিট করতে পারবো না, এই যে গোল গোল এগুলো দিতে পারবো না, বুঝতে পারছো? Okay, okay, understood? A, B, this is C, A, B, this is C. Understand the design? How I divide the expression and how I take the expression and then remove that and make the design. Understood? So remember, you have to practice this so that you do not have to consider something as X, something as Y, something as Z. You do not have to consider. At some moment, after seeing the expression, you will be able to design it. You do not have to think about something else. Okay? Now let's have a practice. Let's have a practice. Okay? Everyone? Okay. Now, design this. Y is equal to AB plus CD. Okay, design this. Remember, there is no bar. Okay, design it. And can you give me a picture in the messenger group after designing it?
What will design, sir?
So design it on paper and take a screenshot or take a photo and share it in the our Facebook Messenger group. I want to see whether you did it all or not. Okay, can you do that?
Yes, sir.
Okay, do it, please.
Let us try, sir. Let us try. Sir,
Yeah,
show us again, please.
this one.
Thank you, sir.
Okay.
Sir, I tried.
Okay. You send me the picture.
Yes, sir, I seen it.
Okay. I'm checking. Yeah, the later part, the bottom part is okay. Okay. Who are you? Yusuf Ali Noor, right? Yusuf Ali Noor.
Yes, sir.
The bottom part is okay. Okay, let me show you. No, okay. The bottom part is okay, but your top part is not okay. Okay, because I told you before, CMOS means you have equal amount of NMOS and equal amount of PMOS, right?
Okay.
So if you have 4 NMOS at the bottom, you should have 4 PMOS at the top. And you made mistake drawing PMOS as well, because those are not PMOS, those are NMOSs. So you have 6 NMOS
Yes, yes,
there. Okay, so try it again.
Okay.
Let's see 1 more minute, then we will solve it.
Okay, sir.
Okay. Anyone else who can share something like that? Okay, let me show you. Okay, who did that? 25 batch, right? Okay, this one. Can you see my Facebook page? Can you see my Facebook? Yeah, you can. This, not this. 25 batch, 25 batch. D25. Now here. Who gave me this design? So you are Abbas Said. Abbas. So
Yes, sir.
your design AB plus CD. No, you made a mistake. What is the mistake? Let me show you. This is your picture, right? You can see on the screen.
Yes, sir.
Okay. Why do you make mistake? See here. So this one. This is a mistake. What will happen? You should connect the gate together. From there, you should give the connection, and this one will not be there. Okay, let's redraw it with white color. There will be nothing like that. And your output should come from here. Okay, Abbas?
Okay, okay, sir. Yes.
Your output should come from here. And you have made one more mistake. That is this combination, A, B, and CD. This combination will be at the bottom. Okay? A, B, and CD. This combination will be at the bottom. And this combination will be at the top. Understood?
No.
Okay. You do not have to be panicked. I will let you understand. No problem.
Yes.
Okay. Let's see who else submitted. Abbas submitted. Nazib. A, B, C, D. Okay. Good. Very good. 100% correct. Who is that? Nazib, right? Nazib. Excellent. You did it right. Okay. How he did that, I'm going to explain. See, everyone. Can you see the screen? Now, our expression was AB plus CD bar, right? So our expression was Y is equal to AB plus CD, not bar actually, right? This was the expression. Can you see that? So if I tell you to divide this expression into two parts, how can you do that? Obviously, you have to do like this: AB plus let's say M plus N, right? This will be an answer. This is the division. That means your AB will be M and your CD is N. Understood? This is how you should what? This is how you should separate your you should simplify your expression at the first moment. Now M plus N, they are what? They are added, right? They are added. That means they are they have to be ORed, or you have to use OR gate, right? That means addition. Addition means what? Who can tell? Addition means what? Addition means what? Addition means your NMOS should be what?
Should be parallel, sir.
Your NMOS should be parallel, right? Yes, exactly. Your NMOS should be parallel. So let's write. So parallel means this part is your NMOS. So this is your M. This is your N. They are parallel. Parallel means they should be connected like this. And here you will have your ground.
Ground.
Okay. Then in PMOS, what should they do? They should be in series, right? This is your M. This is your N, right? Understood? So now at the middle, remember your output will be always from the middle of your PMOS and NMOS. At the middle of your PMOS and NMOS will be your output. So since we do not have any bar, so these should be connected with what? With our NOT gate. Okay? This should be connected with our what? NOT gate. Understood or not? Understood or not?
Yes, sir. Yes.
Okay. Now, your M is not M. Your M is actually AB. So we can erase that and we can write AB. We can write A and B, right? We can write AB. Now, AB is addition or multiplication? A into B. See, A into B. Multiplication. For multiplication, NMOS is what? Series or parallel? Series. So here we will have two NMOS, but both of them will be series, right? So let's erase this, and we are going to apply some what? We are going to take this. Oh my God! Oh, no. What happened? So one NMOS. We need one more NMOS. Like this. Okay. Then they should be in series. Okay, they are series. Now think about N. N means what? N means CD, right? CD. They are multiplied. So for multiplication, NMOS should be what? Series. Agree? Agree with me?
Yes, sir.
NMOS should be series. Okay. So I'm going to take that and make some series connection. there, there. Okay. For M, M means what? For M is AB, right? For PMOS, see, M is AB, AB, right? Now AB is multiplied. For multiplication, PMOS is what? PMOS?
Parallel.
Parallel. So these two AB should be parallel here. Okay. Let's see. This is one PMOS. We will take another PMOS. Parallel. For N, N is what? CD, right? CD is multiplied here. That means they are series in NMOS, but they should be parallel in PMOS, right? They should be parallel in so we need these. Okay. Clear all the drawings. Don't need it. Give all.
স্যার এটা কি যেটা সলভ করতেছিলেন ওইটার?
হ্যাঁ, যেটা করলাম। Now look at this again. I'm going to okay. Now what happened here? আমি আবার ইয়ে নিয়ে আসি। Now what happened here? This is our M, okay? This was our N. This is our M. This is our N. See, M and N, they are parallel, right? So see, M and N, they are parallel. Here, M and N should be what?
Yes.
Should be series, and they should be connected, right? From the middle, we should take our output. So M kintu ki hoise, for M was AB. AB means A into B multiplication. For multiplication, NMOS should be series. So say, see, this is A, this is our A, this is our B, right? A and B, they are what? I mean, likhe dilam ekhane. This is our A, this is our B. See, A or B, they are series. This is our C, this is our D. They are series as well because N was C into D. C into D means NMOS se tara series hobe. In NMOS they will be series. See, they are series. And AB and CD, they were plus. That means M plus N. M plus N. So they should be parallel. See, they are parallel. It's a blue color. Parallel. And at the bottom, they should have their what? Ground. Understand? Okay. Now for MN at the top, since they were series here, so at the PMOS, they should be what? They should be definitely parallel. So here, this is our A. This should be our B. Since C and D are series here, so they should be parallel here. This is our C and this is our D. Understand? Okay, let's erase some part. We do not need these. We do not need these. We do not need these. Need these. Oh, we have to give the ground, the NMOS. We have to give the connections as well. We do not need these. Do not need these. Okay. Now, last thing we have to do, that is we have to give the connections of this one. We have to give ground here. We have to connect these, finally these. Understood? Have you understood?
Yes, sir. Sure.
I believe you so. So I'm going to give you some work today, and this will be your assignment for tomorrow. Okay? Agree with me?
Assignment or midterm assignment, sir?
No, not midterm assignment. Just a homework assignment. Because if you do this, I believe your midterm grade will go up by 1 grade. If you do this, obviously this is not applicable. This is not applicable for all students. Not all student means if you are a very bright student, if you are a very good student, you do not need this because you know it. You have understood this, right? You will not forget it. But if you are an average student or a bad student, I'm not saying bad student. If you are an average student, this will help you big time in your midterm and in your final time because you will know what sort of design you might see in the mid or in the final. Okay, so that's why I'm going to give you 5 design today. Five designs today. Tomorrow in the class, during the class, you will submit all the designs. Can you do that?
Of course.
Yes, sir,
Of course, right? Of course. I'm going to give you the design. You take a screenshot. Here I'm going to write your design. It should be here all designs. Not this, not this. Okay, this one. Number 1, F1 or let's say Y. Let's write Y. A plus BC okay, there will be a bar. 2 is equal to Y equal to bracket A plus B bracket. This one is extremely easy. Extremely easy in a sense. This is completely opposite the design we have done right now. This one, the number 2. Number 2 is easy. Number 3 will be Y equal to A plus BC plus D. 4 will be Y equal to A plus BC dot D plus E. This one is huge. This one is big. I know that. Okay. Okay. Let's stop here. Okay. Let's 4. Now I need some bar. I need to give some bar. Okay. Let's give a bar here. So bar is normally actually a very easy thing, right? You understand what is bar and what is not.
Yes.
Bar means you have to give a NOT gate or not, or you have to keep it like that. That's it. So this 4 are your design. Okay. This 4 will be your design. I'm going to give you a screenshot. Submit this 4 design tomorrow. If you do it by not taking any help from other person, I am sure that you will be able to do any design by yourself. Okay, if you can do it. So I'm going to give these in your Facebook group. Okay, why you need it? Why we need this? Okay, let me show you something. Okay, I'm going to stop the share. Now I'm going to I'm going to stop the recording. Then I'm going to give you that. I'm going to show you that.